Okay, welcome back again. This is the Chipmaster here. Alright, so today I'm doing another laptop repair, right, on another Apple. Right, in my last video was an Apple. I have here another Apple, and the tech gave it to me and he said that it has no backlight. Right, so taking this machine now out of the plastic. See? Alright, so the complaint is no backlight. So I'm going to check it. As a matter of fact, the model is an A2338. Alright, so the model is an A2338. Alright, so alright, there you have it. It's an A2338 model. Alright. Okay. Alright, so I'm going to power the unit. Alright, so I'm plugging in the power. What? What the? They said that it has no backlight. Okay, so this port works, but something is going on this port. Alright, let me see if I see anything. I'm pressing the touchpad, but I'm not getting the click. Huh? You see that? I touch the button, and as you can see, it's now doing something abnormal there. It's not boosted anymore. I just touched the button and the entire laptop shut off. Trying again here. See? I'm not getting the display to stable output display here. See? So this laptop is a dead laptop. And they say that it's a backlight issue. That's miscommunication right there from the tech. Right, so it's not turning on. It's not turning on at all. Alright, so as you can see, it's on this port, it keeps doing this. On the other port, I get something. See? So this is a dead laptop. This is a dead laptop. Alright, so as you can see there, it boosted before, turns on, charges the battery. As I hit the power button, it shut off immediately. And now it's stuck into this boot loop problem on both ports. Alright, so I'm going to check the resistances on the Type-C port here. To see if I can fix this thing. Alright, so on the A side, I'm checking the A side first. VBus, I get 136. Configuration channel, which is A5. All good. Let me go to the B side. Alright, so B, VCC, this is B4. Alright, B5, configuration channel, all good. Alright, let's go to the next port. Alright, B4, VCC or VBus, all good. Configuration channel, 620. Alright, let me flip over to the A side. Alright, A4 VBus. Alright, A5 configuration channel. Alright, there's no chart there, 620. Alright, so I'm going to disassemble the machine and see what's going on inside. Alright, so the back cover is open so far. Alright, so I'm just going to check for some visual inspection. Alright, this is the nonce. Alright, don't see anything there. Alright, let's check up here. These are the coupling capacitors here for the Thunderbolt. All is well there. This is the audio amplifiers. All is well there. No liquid intake. And the keyboard section and the charging section here. Alright, this is the charging coil here and the keyboard. All is good. And this is the audio chip. Alright, this is the audio section here. No problems there in terms of liquid or any explosion. Alright. And the backlight section here. Seems good. Alright, so I haven't seen anything obvious. Alright, so let me remove the battery. Alright, so I'm going to continue the disassembly and get back. Alright, so now the board is out. Alright, so I'm turning over now to this side to see if I see anything. Alright, so take a look. Alright, so these are the power delivery chips and I'm not seeing anything there. Alright, this is the backlight output coil, Wi-Fi, all is well there. Okay, so this is the charging section here, all is well there. And I haven't seen anything, and these are the other audio amplifiers and they are all good. Alright, so everything is good in terms of visual inspection. Alright, so I'm going to check some resistances now on these coils and power sections and so forth. So first I'm going to check on PP bus. Alright, so PP bus discharges, and now it's 484. PP bus is good. Also, this is a backlight section. That's ground. Okay, that's good. Backlight circuit is good. And here, that's good. 1 volt S2 is good. Alright, so I'm going to go under here now to check PP 3.3, PP 3.8 volts section. Alright, so this is PP 3.8 and these coils are in parallel. Alright, so I'm going to check here for these. There's in a shorting. All is well, 142. So there's no short. And this is the PMU IC, the master PMU IC. And all is well in terms of a visual inspection. So PP 3.8 volt, no short. Alright, so I'm going to get the Type C port. Okay. Alright, so the port is plugged on. So I'm gonna plug in the power. Oh, first of all, I didn't check the resistances on the power delivery chips. How could I forget that? Alright, so under the microscope for the power delivery. Alright. Oh, we have some liquid corrosion here. Is that liquid? Oh, I thought it was liquid. Alright. Alright. So far, everything is good so far. Alright, let's see the next one. Alright, that one is good. Yeah, that's good. Okay, that's good. Alright, excellent. Everything is good. PPDC in. Okay, that's good. All well. Alright, so I'm going to plug in the power. I'm going to check if I'm getting 3.3 volts LDO 3.3 volt, S2, and so forth and so forth. Alright, so this one 0.6, 1.5, yes, that's correct. 3.2 volts, and it goes away. This one, and it's doing the boot loops thing over and over again. Let me try the other port. .2 off. It should be 1.5. Alright, and it's gonna go. It's gonna come and go and do that in a loop continuously. It's 5 volts there. Alright, so this is it's doing the same thing. Alright, I'm just checking the EEPROM chip power supply. 3.2 volts is okay. Alright, so I'm going to check with oscilloscope the reading on this pin number 1. Alright, so pin number 1 for this chip. Alright, so as you can see, this is the ROM chip. Alright, this is the ROM chip. Alright, so I'm going to check on the pin number 1. Alright, so I'm going to measure pin number 1. I'm going to see if the resistance is connected, because it normally has to be connected to a pull-up resistor. Sorry. Alright, so it's that resistor there. So anyone should work. Alright, so I'm going to put my probe here. Plug in the power. Alright, so I got a reading there, as you can see. Okay, so the EEPROM is being read by the power delivery chip, and it's doing this in a cycle. Right, so that indicate that the chips, these power delivery chips here are actually going out to read. So I'm going to go to the next port. To see. Alright, so I have a reading there. Reads and stops, and then it's gonna do this in a loop. Alright. Alright, so it's reading the chip. Normally if the chip is not good, it has to try again and again and again. So it does that in a loop. So I'm going to program this chip first and see if it is actually being detected on the programmer. Right, so I'm going to program it. Okay, so the RAM chip now is in the socket. Alright, so I'm going to close it, and I'm going to try and program this device, this chip. Okay, so I'm now on the schematic. Right, so to locate the ROM and the model of the ROM. Right, so this is the Thunderbolt, and here are the ROM, the power delivery chip, and this is the ROM chip UF260. Alright, so UF260 is the W25Q, which is a 1 megabyte, and it's a 0DV. Right, as I see, as I explained this chip before, it uses the quad SPI or the quadruple SPI, right, which is these pins can act as an input and output, and it's 4-bit 0, 1, 2, 3. All right, so this is the model. I have to make sure that I know, it's because it pops up with more than one model, so I have to select the correct one. All right, so I'm going to select read ID. Alright, so this is the one I wanted, which is WQ25333 3.3 volts win bond. Alright, so I'm going to select that one, and I'm going to rewrite the program. Alright, so it's an A2338 UF260. Open, and I'm going to hit auto. IC will be erased, and say yes. And as you can see now, the ROM is now being erased, blank checking, and then erase, and then write, and then verify. Alright, so it's now programming the memory. Alright, it's now verifying. Alright, so it's completed. Alright, so it's now completed. Removing the programmer. Alright, so I'm going to solder the ROM back to the board. Alright, so I'm now removing the excess solder. Okay. Oh, I have some new sponge. I want to try. See how well this sponge works. Wow. Alright, not bad. Okay, so I'm going to plug the power in now and see if there's any changes. Alright, so I'm plugging in the power. It's now stable at 5 volts. It's not boosting still, but it's not restarting. As you can see, it's not restarting. Before it was jumping, pulsing back and forth. Alright, let's try the other port. I'm not getting a boost. Let me see if I'm getting 3.8 volts. Yes, I'm getting 3.8 volts. I'm getting 3.3 volt S2. But I'm not getting a boost. Okay, so after doing some checks, I pounced upon this component here. It has some corrosion, as you can see here, has some oxidation, and also a part of the motherboard layer there. The mask is scraped off, right? So I realized that there was a liquid here. As you can see, I have some oxidation here as well. All right, so the chip is removed. So the chip is here. Where is it? Oh, right here. Right, so this chip is going to provide 1.8 volts. I'll show you shortly on the schematic. Alright, so here is it. So I have some small oxidation on this chip part here, right, which is coming from this part. So as you can see, it's not making proper contact, right? So over to the schematic. This is the chip, right? So as you can see, it's a typical switching type of a chip, like a integrated MOSFET at a V in, and it has an output, right? So whatever voltage is coming in, right, that's the voltage that is coming out, as you can see, which is PP 1.8 volt underscore S2 underscore switch, right? So this is the internal MOSFET that sits inside, that's a switcher, right? So this is a power method that is used by most manufacturers, right? So this is a MOSFET that basically takes an input. So whatever is coming in, the same thing coming out. So it's not a voltage regulator. A voltage regulator has different voltage inputs and outputs, right? So the voltage on the input is different from the output. So this is not a voltage regulator. As you can see, this is the power supply, which is VDD for the chip, pin number 1, right? After it gets the power supply, then 1.8 S2 will be generated to pin number 3, right? So it needs an on signal, as you can see here, and this on signal is coming from here, which is PVDD1 underscore power underscore EN, right? And it's coming to both of these chips. As you can see, this is UC820, right? And it's coming to pin number 2, right? And it's going to pin number 16, right? So this chip is a 2-in-1 UC840, right? And I have UC820, right? So they are similar, right? So it's unusual for this has pin 16 and this one on is pin 2, right? So you have 1, 2, 3, pin number 4. So this chip is split into several pieces. Interesting. Alright, so it's VDD 1.8 volt switch. I only see 2 chips on this board, on this page here. Alright, that's PP3V2S2. I already checked that, that's coming. Alright, so this is coming to pin number 1, and pin number 1 on the board view, as you can see, is right here. So this is the oxidized part. This is a capacitor here. So this is all oxidized. This is, I have to remove this because the solder joint is oxidized, right? So this is okay. This capacitor is okay. So I need to just resolder back, clear this path, right? Retin this section with some solder, fresh solder, and resolder it again, and see what happens, right? Okay, so I will resolder the chip. Okay, so this is the results. So what I did is I didn't bother to put back the chip. So based on the schematic, I realized that it's just a switcher. So all I had to do was to just run a jumper wire and solve the problem. So I will now clean the board with 99.9. This was the section that was actually causing the problem. So the 1.8 volts S2 was supposed to be 1.8 volt switch that is going to the M2 CPU, right? And another thing, I made a mistake that I flashed the incorrect ROM file inside of the ROM chip for the power delivery. The file is actually for an M1, so the M2 file was a bit different, so I had to find that M2 on the board, copied that file, and then I write it on this one for this board, which is a M2, not an M1. Alright, so alright, so the board is now clean. Okay, so I'm going to plug in the power now. I want to do this on the overhead. Alright, so I'm going to plug in the power. Alright, so let me see if the switch is on. Did I give power? Yes. Alright, there we go. So I have 5 volts and it's now boosting to 20 volts, as you can see, and the current, as you can see. Alright, so it's on. Alright, so I'm checking here if I'm getting 1.8 now. Right, as you can see. Oh, sorry, I'm on AC voltage. Oh, my meter probes are not plugged in. Right, so I'm getting 1.8 now. I wasn't getting 1.8 before. Here. Right, so this is 1.8 volt switch, which is going to the M2 CPU. Right, so I'm going to connect I'm going to put back the board inside of the case, and then I'll see what goes from there. Okay, so the laptop is now assembled. Alright, so I'm plugging in the power. There we go, Apple. Alright, this version of the macOS on the selected disk needs to be reinstalled. Alright, so I'm just selecting the Alright, so I'm just restarting. The assurance. That's the sound that I want. There we go. So we have the progress bar loading up. So beautiful. And the touch bar is now on. And there we go. We have image. And the login is there. Alright. So that's a done job. And the battery is charging, as you can see. Oh, let me... Alright, so as you can see, I'm grabbing 2.8 ampere there. So the battery is charging lovely. Alright, so that concludes the video. So I hope you learned something and enjoy the video. See you again in another repair video.